Hello, guys. We're gonna start our session. Okay, so our session for today is we're still discussing binomial theorem. Okay, we're still discussing the binomial theorem. So let me put that here as our heading, binomial theorem. We're still discussing the binomial theorem, but now what we're looking at today. We're gonna look at the last part of the discussion. Today we're gonna look at finding the rth term. Okay, we're going to find the rth term of our binomial expansion. Okay, so we're going to find, let's say, it's, the rth term, and now the rth term means finding a specific term of the expansion without calculating the whole expansion. Okay, finding a specific term of the expansion without calculating the whole expansion. All right. So let me write the expansion again. Here we got a plus x, okay, to the power n. And of course, we know that this is equal to a to the n plus n, a to the n minus 1 multiplied by x plus n times n minus 1 divided by 2 factorial multiplied by a to the n minus 2 multiplied by x to the 2 plus, you can go all the way to the last term of this, which is x to the n. So this is our expansion here. And what if now we want to find the rth term? Okay, we want to find, okay, now we want to find the rth term. We want to find the rth term. We want to find the rth term of this expansion. We want to find the rth term. R is any number, okay, any natural number. Let's say the first term, second term, third term, fourth term, any term. So R stands for any natural number, really. So we want to find the rth term of this expansion. All right, we want to find the rth term of this expansion. We want to find the rth term of this expansion without having to calculate the expansion. Okay, without having to calculate the expansion, without having to write out the whole expansion. So we want to find the rth term of this expansion without having to write out all the terms of the expansion. Okay, so the formula we use for this is the following formula. We use n and you know, this formula I will also give you guys in the formula sheet. So we got n multiplied by n minus 1 multiplied by n minus 2, and then this goes all the way to n minus r minus 2. So we go n times n minus 1 times n minus 2 times all the way to n minus r minus 2. Okay, and we divide this by r minus 1 factorial multiplied by a to the n minus r minus 1 multiplied by x to the r minus 1. Okay, in this case, r is any number, but r must be at least 2. Okay, so r is at least 2. R is any number, but it must be at least 2. Okay, and of course, when I say any number, in this case, I mean any natural number. Okay, it can't be a fraction. R can't be a fraction. R is either 2, 3, 4, you know, and so forth and so on. It must be at least 2. At least 2. All right. Okay, so this is the formula we use for this. Now we're going to look at an example where we apply this formula. And as I said, you don't have to remember this formula off by heart, but you have to know how to use it, obviously. I will provide this formula for you, or provide this formula to you in the formula sheet. So now let's look at an example now. Let's look at an example where we apply this formula. Okay, let's look at an example where we apply this formula. So I'm going to say examples. Let's look at an example. I'm going to say examples where we apply this formula. So we're going to look at one day given in the textbook in the exercise. Let's go to the exercise 94. Okay, we're going to go to practice exercise. Let's go to practice exercise. This is where I take these examples from practice exercise 94. Let's go to practice exercise 94, and we're going to look at. Let's look at number 7 of that practice exercise. Let's look at number 7 there. Number 7 of practice exercise 94. If you look at number 6 there, they say determine the 6th term of that binomial. Okay, that's number 6, but we're going to look at number 7. In number 7, they say determine the middle term. So they don't tell you, they don't say 6th term or 5th term or 4th term. They don't state it like that. They say determine the middle term. So you have to figure out which term is the middle term. Is it the 6th term? Is it the 8th? Is it the 5th term? Which term is the middle term of that binomial? Okay. So now, okay, so that's the example. They say determine. They say determine the middle term. That's what they say. Determine. They say determine the middle term. Determine the middle term of the following. So determine the middle term of 2a minus 5b. So determine the middle term of 2a minus 5b to the power 8. Determine the middle term of 2a minus 5b to the power 8. So now over here, we are not going to expand. We're not going to find the expansion of this. That's the whole point of this formula. We want to determine this middle term of this expansion of this binomial, or of the expansion of this binomial, without having to list all the terms of the expansion. So this simplifies things for us. So now, how do we then apply this formula that we just discussed? How do we apply this formula to go and determine the middle term of the expansion of this 2a minus 5b to the power 8? Okay, so first of all, let's go look at the formula and see what the formula. So this is the formula here. So obviously, in this case, we've got 2a minus 5b to the power 8. Okay, we want the middle term. First, we need to know which term is the middle term. Which term is the middle term? If you go to the formula for the expansion, a plus x to the n is equal to a to the n, so forth and so on. How many terms does the formula have? Okay, if you have n, if n is your power, if it's a plus x to the power n, how many terms are you then going to have in your expansion in general? Well, if you notice how the formula is structured, you'll notice that you always want to have n plus 1 terms. Okay, so for whatever n you have, a plus x to the n will have the expansion for a plus x to the n will have n plus 1 terms. So have n plus 1 terms. You can check this. You can check this even in the previous exercises you did or examples you did. You'll see that for a particular n that you have, the number of terms in the expansion will be n plus 1. If let's say you got a plus x to the 2, your expansion will have 3 terms. If it's a plus x to the 3, your expansion will have 4 terms in total. So it's always n plus 1 terms. So in this case, they say find the middle term of this. We've got 2a minus 5b to the power 8. So our n is 8 here. So meaning that the expansion of this binomial will have 8 plus 1 terms, which is 9 terms. So the total number of terms of the expansion will be 9 terms. Now, if you look at 9 terms, which term will be the middle term? Okay, which term will be the middle term out of 9 terms? So which is the middle number? If you got 9, if you got 1 to 9, okay, middle number is obviously 5. Okay, so if you look at 1, 2, 3, 4, 5, 6, 7, 8, 9, the middle number there is 5. So meaning that if you got 9 terms, the middle term will be the fifth term. So therefore, they basically, when they say determine the middle term of this expansion, what they are saying is that find the fifth term, determine the fifth term of this expansion. Okay, so we say, so we have to, okay, so we have to determine the fifth term. The middle term of this expansion will be the fifth term, because the expansion in total, it has 9 terms, and the middle term of 9 terms is the fifth term. Okay, so the middle term of this expansion is the fifth term. The middle term of this expansion is the fifth term. So we have to determine the fifth term. So now, meaning that when dealing with our formula here, that is that means that R is equal to 5. Okay, R is equal to 5. So therefore R is equal to 5. R is equal to 5. So now let's go back here. So if R is equal to 5, what is then R minus 2? Because we need to know when we stop over here. We're gonna go n. In this case, of course, n is 8. So we're gonna go 8 times 7 times 6 and so forth. We need to know when we're gonna stop. So what is R minus 2? Okay, what's R minus 2? If R is 5, then R minus 2 is equal to 5 minus 2 is equal to 3. Okay, if R is 5, R minus 2 is 5 minus 2 is equal to 3. So then we stop when we have 3. Okay, so let's go ahead then and apply this formula. Let's go ahead and apply this formula. Let's go ahead and apply it. So we're gonna go in the top. We have n times n minus 1 times n minus 2. So meaning that we've got since n is 8 in this case, meaning that we've got 8 times 8 minus 1, which is 7, times 6. We're going to go all the way to times 8 minus 3, because R minus 2 is 3. So we're going to go all the way to 8 to times 8 minus 3. Okay, so let's see how this works. Let's do it. So we have 8 multiplied by 8 minus 1, multiplied by 8 minus 2. Okay, multiplied by 8 minus 3, and this is where we stop, because R minus 2 is 3. So it's 8 times 8 minus 1 times 8 minus 2 times 8 minus 3, and we stop there. And we're going to divide this by R minus 1 factorial. R, of course, again, is 5. So 5 minus 1 is 4. So R minus 1 factorial is 4 factorial. And we're going to multiply this by A, multiply by A to the n minus R minus 1, meaning that we're going to multiply by the following. In this case, in place of A, we've got 2A. So we're going to replace this with 2A. We're going to put this to the n minus R minus 1. If you look at the formula, that's what it says. Okay, we times this by A to the n minus R minus 1. But in our binomial that we have, instead of A, we've got 2A. So in place of A, we're going to put 2A. Okay, and instead of in place of n minus R minus 1, of course, we're going to put 8 minus R minus 1. And R minus 1 is 4, because R is 5. So R minus 1 is 5 minus 1, which is 4. So we're going to put we're going to put 4 here. So it's 8 minus 4. And then we're going to multiply by x to the power of R minus 1. But in place of x, we've got minus 5b. So we're going to put minus 5b and put this to the power of R minus 1, which is 5 minus 1, which is just 4. So we're going to put this to the power of 4. And then we are going to simplify this. We're going to simplify this and get our answer. Now, how do we, okay, let's simplify this. Let's simplify it and see what we get. Let's go ahead. Okay, let's go ahead and simplify it. Okay, let's go ahead and simplify this. Let's go ahead and simplify this. So we got 8 multiplied by 7 at the top. That's 8 times 7. Okay, times 6 times 5. So it's 8 times 7 times 6 times 5. Okay, all right. And we divide this by 4 factorial. And we multiply this by 2 to the power of 8 minus 4, which is 2 to the power 4. So 2 to the power 4, multiply this by 2 to the power 4, and then we sorry, just go back there. Multiply this by 2 to the power 4 and multiply this by minus 5 to the power 4. Minus 5 to the power 4. Okay? And that will give us a 700,000. Okay? Let's write it down. Just work it out in your calculator. You see, it's going to give you a 700,000. 1, 2, 3. So a 700,000, and multiplied by a to the power 4. So it gives us a 700,000 multiplied by a to the power 4 multiplied by b to the power 4. Okay, so that's the answer we get here. So this is the middle term. So that's how you use the formula. Now this gives us the middle term of this expansion of 2a minus 5b to the 8. Okay, that's how you calculate it. Simple as that. You just apply the formula. Now, I want you guys to also do number 6 on your own. Number 6 of this practice exercise 94. In number 6, you have to determine the 6th term. In number 6, you determine the 6th term of 3p plus q over 3 to the power 13. So in this case, they tell you what r is. R is equal to 6. They say the 6th term. So r is 6. So you just go ahead and you apply the formula in the same way we applied it for number 7. Okay. Now let's move on then to the next thing. What I want us to discuss next is the following. I want us to discuss the following now. Okay. Let's look at this. Now, if you have the expansion here, okay, let's look at the expansion of 1 plus x to the n. So say you got the expansion of 1 plus x to the n. Okay, and again, expansion of 1 plus x to the n is just when you replace a with 1. This is equal to 1 plus nx, okay, plus n multiplied by n minus 1 divided by 2 factorial multiplied by x to the power 2 plus it goes on. It goes on if, of course, depending on what n is, obviously, it's going to have a finite number of terms or it's going to have an infinite number of terms. But if it's got finite number of terms, your last term is x to the n. But anyway, sorry, let's fix this. Okay, I'm back, guys. So as I was saying here, so this is the expansion. So if you have this expansion, and as we discussed before, depending on n, depending on what n is, whether n is negative integer, or whether n is a negative integer, or is a fraction, or is a natural number, this expansion will be finite or infinite. Okay, but just in general, whether it's finite or infinite, in general, okay, in general, if the number x, if x is much less than 1, if x is less than 1, okay, or if x is we can say if x is much smaller, if x is much smaller when compared to 1, we can write this like this. If x is much smaller, we write with a double less than symbol. So if x is much smaller than 1, then you can approximate this expansion. You can approximate it by just using the first two terms. Okay, so if you find that the x you have, if you deal with any situation where x is much smaller than 1, then you can approximate the expansion in the following way. Okay, you can approximate it. You can say that 1 plus x to the power n is approximately 1 plus nx. So you can approximate it. Okay, so if x is much smaller than 1, then you can approximate this. You can say 1 plus x is approximately 1 plus nx. So you can approximate it. So now this works, of course, as I guess for this expansion of 1 plus x to the n, when a is 1, if you have 1 plus x to the n, not a plus x to the n, 1 plus x to the n, it works for this. And again, if x is much smaller, than 1, then 1 plus x to the n is approximately 1 plus nx. So you can approximate it. Now, let's look at the examples here. Again, we're going to look at examples of this. Let's look at examples of this. Okay. Let's look at examples of this. Okay. Look at examples of this. Now, let's go to, again, the textbook. We're going to look at practice exercise 95. Okay, let's look at practice exercise 95. Let's look at practice exercise. Practice exercise 95. Okay, now this is on page, let me just also give you the page of this. This is 199. Practice exercise 95 on page 199. So this is on page 19. This is on page 199 over here. Okay, so let's look at that exercise there. Let's just go and find one example of this in that exercise. Let's look at let's look at number number 7 again. Let's look at number 7. Number 7, when they say when x is very small, show that 1 over 1 minus x to the power 2 times 1 times the square root of 1 minus x is approximately 1 plus 5 over 2x. So show that, so they say when x is very small, show that 1 over 1 minus x to the power 2 times the square root of 1 minus x is approximately 1 plus 5 over 2 times x. They say show this. So let's do that. Let me just write it down. So now in the exercise there, this is number 7. In the exercise there, this is number 7, guys. And it's number 7a. Okay, they say show that, they say when x is very small, they say when x is very small, they say show that, okay, when x is very small, show that 1 over 1 minus x, so it's 1 minus x to the power of 2. Okay, so when x is very small, show that 1 over 1 minus x to the power 2 multiplied by the square root of 1 minus x. Multiplied by the square root of 1 minus x is approximately, so it's 1 over y minus x to the power 2 times square root of y minus x, show that it's approximately 1 plus 5 over, okay, let me just repeat that. It's 1 plus 5 over 1 plus 5 over 2, 1 plus 5 over 2x. So show that this is the case when x is very small. Show that 1 over y minus x to the power 2 times the square root of y minus x is approximately 1 plus 5 over 2x. Okay, so show this when x is very small. So let's go ahead and do this, okay? Obviously, we're going to use our conclusion here, okay? We're going to use this conclusion here, or our condition or conclusion. But either way, it's true. So we're going to use this, okay? We're going to use this, that if x is small as compared to 1, 1 plus x to the n is approximately 1 plus nx. We're going to use that. So let's use that here. Let's see. But first, we need to write this. We need to rewrite this in a way, or in a form that matches this form, 1 plus x to the n. We need to write it in this kind of form, okay? So that we can see, so we can apply this condition or this conclusion or this result. We can apply this result properly. So we're going to write this 1 over 1 minus x to the power 2 times the square root of y minus x. We're going to write it in the form of 1 plus x to the n so that we can easily apply this result. So let's start. So we've got 1 over 1 minus x to the power 2. We multiply this by the square root of 1 minus x. Okay, that's what we have. So this is the same as the following. Okay, first we've got 1 minus x to the power 2 multiplied by the following. It's 1 minus x to the power 1 over 2. So we can write the square root as 1 over 2. Square root of 1 minus x is the same as 1 minus x to the power 1 over 2. Okay, now because 1 minus x is, because the denominator, okay, has the same base, okay, you've got 1 minus x to the power 2 and 1 minus x to the power half. So these two have the same base. Now you can apply the laws of exponents because they have the same base. You can add the powers, or you can add the exponents 2 and half. So this will give you the following. It's 1 over, you can write it as one thing now, as 1 minus x to the power of 2 plus half. Now 2 plus a half is 5 over 2. Okay. So this is the same thing as 1 over 1 minus x to the power of 5 over 2. Because 2 plus a half is the same as 5 over 2. All right, so now we're just rewriting this in the proper form, so we can apply that result we discussed before. So now 1 over 1 minus x, 1 over 1 minus x to the power of 5 over 2 is the same as 1 minus x. It's the same as 1 minus x to the power of minus 5 over 2. So 1 over 1 minus x to the power 5 over 2 is equal to 1 minus x to the power of minus 5 over 2. Okay, so now we have it in the right format. We have it in the format that is similar to this format here. So now we can apply this result. Okay, now to apply the result, we need to note that our n in this case is minus 5 over 2, and in place of x we have minus x. Okay, in place of x we've got minus x, and in place of n we've got minus 5 over 2. So applying this result here for this, we're going to have the following. This is approximately 1 plus nx, but in this case, as I said, in place of n we've got minus 5 over 2. So we replace the n with minus 5 over 2, and in place of x we've got minus x, so we replace the x with a minus x. So that's what this thing is approximated to. It's approximately equal to 1 plus minus 5 over 2 times minus x. If you multiply the minus 5 over 2 with the minus x, you get positive 5 over 2x. So this is basically equal to 1 plus 5 over 2x. So basically, then we have shown that 1 over y minus x to the power 2 times square root of y minus x is approximately 1 plus 5 over 2x. Okay, 1 over y minus x to the power 2 times square root of y minus x is approximately equal to 1 plus 5 over 2x. We've shown that. So that's how you apply these results then to approximate expansions, like to approximate binomial expansions. That's how you do it. Okay. Now, what you can do the rest of those there as an exercise. You can do the rest of number 7. You can do number 7 B, do number 7 B and C. Okay, do number 7 B and C. All right. So do number 7 B and C on your own as an exercise. So we'll stop here. We've covered all the topics for this lecture. Okay. We've covered everything we had to cover for this lecture, is what I mean. Let me just go back and see. So we've covered everything we needed to cover for this lecture. And this is the last lecture for the topic of binomial theorem. So we've covered everything we had to cover for this lecture. And this is the last lecture for the topic of binomial theorem. So what I'm going to do now is after this lecture, I'm going to post it on Blackboard, and I'm going to send you guys your tutorial on the binomial theorem. Okay, so you can go ahead then and do those exercises that I said do as practice. And as I said, I'll also post the tutorial on the binomial theorem on Blackboard, and I'll also send it on WhatsApp. Okay, thank you for joining. Okay, thank you.